Yeah, Gail said he wanted to perform the matrices. Hey, there is a way matrices are arranged, and they usually is a meaning behind it. We usually start with a table such as this. Everybody understands tables, right? So in this table, I've got volume of sales in June. For example, this shop number 1 is selling monitor, printer, and laptop. Shop number 2 happens to be selling the same items, monitor, printer, laptop. Now looking at these two, you need to be able to interpret the data in a table before we can go into matrices. So question, how many printers did shop 2 sell in June?
195.
Oh, okay, that? Okay, how many printers did shop 1 sell in June? How many laptops were sold in both shops combined?
1, 6, 3, 2, 1.
Yeah, 161. How many items did shop 1 sell in June? Okay, how many items did shop 1 sell in June? Okay, 320 plus 358 plus 107, right? Okay, how many printers were sold? Okay, how many monitors were sold in shop 1 in May? How many how many monitors were sold in shop 1 in May? Huh? Yeah. No or don't know? No information. Okay. How many keyboards were sold in shop 2 in June? No information. Okay. So this is all that we have. And this is all that we are going to use for matrices. So we are going to transfer all this information into this. So instead of drawing tables, instead of writing the heading, this and that, we literally transfer all the numbers into a matrix like this. Okay? So we are going to just have 6 numbers, 320, 358, 107, 216, 195, and 54. If I did not give you a context, if I didn't give you the story behind it, I just give you this. Do you know what the numbers represent? No, right? But what you do know is that these numbers over here are related. That's why they are in a row. Okay? There is a relationship between them. Now that we know the story, what is the relationship for the 3 numbers in a row? They are from the same shop 1, right? Okay. What about the information in this row? They are all from shop 2. Okay. Then we also know that the numbers arranged in columns, there is also a meaning. If I didn't tell you all this information, we don't know what the numbers represent. But now we know the story. What is the relationship between these two? They represent monitors. Continue. Sold in June. Yes, you will need to be able to write down all these keywords in your subsequent maths questions. So I'm sure you can tell what these are and what these are. Okay. And we use curved brackets at the sides. So can you imagine if I've got shop 3. So let's say this is 1, 2, and 3 for convenience. Then our matrix will grow, isn't it? And it will grow to look like this. Okay, so how you write is very important also. You must be very neat. So can you imagine if another column, you must know the difference between row and column. So columns are vertical, rows are horizontal. So if I have another column that says keyboard, and this is X, Y, and Z. So I'll include another row another column, X, Y, and Z over here. So matrices can be very, very big. Okay? To contain, the bigger it is, the more information it contains. Sorry? What? What 10 packet? 10 by 10. Yeah, can why? Won't your syllabus won't be 10 by 10 Okay? Now, some terms you need to know. This is a rectangular arrangement. Okay, they call it array Next time if you do programming, right, you will learn the word array also. But just call it a pattern. This rectangular pattern of numbers is called a matrix. 1 matrix, 2 matrices, 3 matrices. numbers, all these things inside, they are known as elements. Okay, elements or entries. Usually we use elements, and we identify an element by its row and column position in a matrix. So let's say I want you to describe this position. Okay, this is not a good example. If I want you to describe this position, how do you describe this position? Oh, what? Row 2, column 2. Do we start with row or do we start with column, or does it or it doesn't matter? It matters, right? Because, yeah, exactly, just like your x and y axis. You must read your coordinates with the x coordinate first and the y coordinate first, so that I know exactly where you're talking about in the Cartesian plane, the x and y axis lah, okay? Likewise, in our matrices, we've got our row 1, we've got row 2, quite natural, right? We put row 1 on top, row 2 below, row 3 at the bottom, and so on and so forth. And then we read from left to right. So we put column 1 over here, then column 2, column 3. So now you need to know that we read by row first, then column. Row and then column. So let us practice. What is the position of this 358?
Row 1, column 2.
Okay, easy, huh? What about this one? Row 2, column 1. Easy? You must remember, no, just as it is important for you to know x first, then y, it is just as important over here. Row, then column. I will keep repeating this. Let's just try this. What is the element in second row, third column? What is the element in the second row and third column? 54. Second row, third column. Okay? Next thing we need to know is the order of the matrix or the dimension. Remember you were saying that the matrix can be 10 by 10, right? Then that tells you the amount of data inside. It gets bigger and bigger. So we don't just talk about, we don't say the size of the matrix. That is not the proper word to use. We use the word order. Order of the matrix. So if a matrix has m rows and n columns, then we say that the order is m times m by n. Okay, this times over here, we call it by lah. Okay, m by n matrix. So spot check. What does m stand for? Number of rows. Again, it's the rows first, right? Rows and column. The order is also written in the same form. Row, then the column. Okay, so we have, for example, back to this matrix over here. What is the order of this matrix? 2 by 3. 2 rows, 3 columns. That's it. As simple as that. Okay. Spot check. What about this one? Matrix A. We use a capital letter to represent matrices, just like sets. Okay. So matrix A. What is the order? 1 by 1. Can you tell that it is a matrix? Or do you think it is just a number? Is it just a number or is it a matrix? Why is it a matrix? How do you know it is a matrix? Because there are brackets around it. Okay? So this is a matrix, it is 1 by 1. What about matrix B over here? 3 by 3, easier. And then we see that you can have negative numbers inside also. And obviously you can have zeros as well. Okay? Now, if the number of rows is equal to the number of columns, it is called a square matrix. It's just a name. Okay? It looks like the number of rows, same as number of columns, so it's a square matrix. Not too important to know about this name, but sometimes we will describe it as such. Next thing, I've got this one, matrix C and matrix D. Matrix C and D, they both have how many? What is the similarity between C and D? Matrix C and matrix D, what is the similarity? They both have one column, yes. What is the order for matrix D?
1 by 3.
1 by 3 or 3 by 1? There's a difference.
3 by 1.
What do we go first? What do we use first? Row first, right? So how many rows?
3 by 1.
3 by 1, yes. Okay, what is the element in the second row, first column for matrix C?
1,
Second row, first column, matrix C.
5.
Okay, very good. If they only have one column, it is called a column matrix. That's just another name. Only one column, it is called a column matrix. So obviously, if I have something like this, only one row, then it's called a row matrix lah. Okay? Okay, so example. Travel agent offers 3 types of overseas tour packages to 4 cities, and the number of customers in each tour in a certain month is shown in the following table. These are the 3 types. You got a standard, economic, and deluxe. Which one do you think is more expensive? Deluxe. Which one is cheaper? Economic. Okay. And then there are 4 cities over here. Represent the data by a 3x4 matrix known as T. Is it easy? Represent this in a matrix called T. You know what? This is an O-level question, 1 mark. Free, right? Might as well take it, right? So this is the answer. Yeah, 1 mark. Better get it. So if you are sleeping, right, you may not know. Huh? Okay. Next, part B. Calculate the sum of the elements. Okay, this one is important, Francis? Sum of the elements in the first column of T. Do you all know how to do it? Calculate the sum of the elements in the first column of T. What do we add? Okay, 58, 64, and 23. Adding them up is not a problem, right? The next part is the problem. What does this sum represent? What does this represent? You add them up. What does it represent? No, be more specific.
The types of overseas package.
The types, no, types, there are only 3 types. Be more specific. Total number of customers going to Hong Kong. Yes. So total number of customers going to Hong Kong. We see all these keywords in the question. Customers. Then total, the word total came from the word sum. Total number of customers in Hong Kong. Okay? All the keywords are given to you. You just need to arrange them only. So next, part C. What is the sum of elements in the second row? Calculate the sum of elements in the second row of T. So second row of T will be this one. Add them all up. You know how to add them up. Primary school kiddos can add them up. Next thing is, what does this represent? So what does the sum represent? Number of customers who chose standard package. That's it. Okay? That's A, B, and C. Okay, so your turn, try it one. Simple stuff. 1 minute, I'm sure you can finish it. Okay, so let's resume. Represent the data by matrix C. I want you to check that you have exactly what I have on the screen. Don't be complacent. Part A. C equals to 30, 14, 35, 49, 32, 27, 42, 25. Okay, do you have the C equals to? Do you all have that? Okay. Do you have the open and close bracket? Do you have 2 very clear rows and 4 very clear columns? Are your numbers very close to each other such that I may think you're writing 3014? Okay, then that's good. Find the sum of elements in the first row and interpret the results. So B, 30 plus 14 plus 35 plus 49. How much is that? 128. Okay. So what does this 128 represent? Come on, what's the answer? It represents number of students. Students. Boys or students? Boys. Number of boys, then continue. Huh? In the 4 CCA. Why you want to say school? Okay, do you see a difference if you change this to in the school? Okay, what does this now imply? Okay, yeah, this if you say that it's the number of boys in a school, it may not be correct. The school may have more than 4 CCAs, right? Am I right? So this is where students tend to lose marks. Please stop playing. This is where students tend to lose marks because they make assumptions. It is not entirely wrong to say that there are 128 boys in a school. If there are only 4 CCA, and if everybody has to join a CCA, then you are right. Yes, there are 128 boys in a school, but you made a lot of assumptions. Alright? That's why we need to be very specific, and I said all the keywords are in the question. In the 4 CCAs. If you just say CCA, then you're assuming that the school only has those 4 CCA, right? So please don't make me have a chance to penalize you. Don't let the marker have a chance to penalize you. Be very specific. Now, part C. Find the sound elements in the third column of C. So 35 plus 42 to give us 77. What does this represent? It represents number of students. Boys and girls are. And girls in, okay, students again. Dance. CCA.
Can just say students, right?
Okay lah, Singapore you can say lah, male and female, yeah, okay. Out of Ali, May and Paul in 3 examinations. You know, in try it 1 and example 1, they give you a table, right? Then you come up with the matrix yourself. Now in example 2, they give you the matrix. You can just imagine a table borders around it. Okay, for English, mathematics and physics. Just a quick check. How much did May get for physics? How much did May get for physics? 65, yes. Who got 82 for mathematics? Okay, good. State the order of the matrix. State the order of the matrix. What is the order?
Oh, 3.
Okay, so we write 3 with a multiplication sign like this. Can? Please don't spell it out. Just write a 3 multiplied by 3. What does the element in the first row and second column represent? Okay, part B, how do we answer this? First row, second column. What?
Wait, second, first row.
First row.
Second column.
Okay, what does it represent? It represents Ali's results for mathematics. Okay. Next, which student has the highest total score? Sum everything up. What do you mean by everything? So what we add? What plus what? Okay, so you add this one up. Sum equals to. So add lah, okay. So add 244, 194, 247. Who has the highest score? They just compare lah. And Paul has the highest score. Easy? So matrices have meanings behind them. It's not just numbers randomly placed anywhere. Okay, so now try it too. How long do you think you need? 2 minutes? Okay, fine, 2 minutes. Okay, next part. Important. 2 matrices are equal, A and B, if they have the same order and their corresponding elements are equal. This is here. If we say that matrix A and matrix B are equal, then I write down A equals to B, and for them to be equal, they must obviously have the same order, right? If the order is different, then the size is different already. And their elements must be the same. The corresponding elements, whatever is in row 1, column 1, must be the same in row 1, column 1. Row 3, column 5, the other side, row 3, column 5. Must be exactly the same. So now, let us look at A and B. Are they equivalent? Are they equal? Why not? Okay, so row 2, column 2, they have different elements, right? Do they have the same order? Yeah, they have the same order, but that's not enough. Okay, let's look at, let's compare B and C. Are they equal? Why not?
Different column.
Di-
Different number.
different
of columns.
order. Okay, use the correct term. They have a different order.
Yeah, cannot say different number of columns.
Yeah, you can say different number of columns, or you can also say that they have a different order. Okay, because the order comprises the row and column. Okay, what about C and D? Are they the same? Why not? C and D, are they the same? No, they are different also, right? Because they have a different order. Then out of all these, are there any matrices that are the same? A and D. Are they really the same? Do they have the same order? Do they have the same order? Yes, right? 2 by 2. Do they have the same elements everywhere? Yes lah, because this one
It's like
6 2 times 3 6 Then 2 cube is 8 Okay, so they are the same Is that the end of our lesson already?
Yeah.